Hi everybody. Today we're going to look at factors and see how they can help us solve some problems. So we're going to start with describing what a factor is and then some terminology that goes with it. So if we start with what a factor is a number that divides into another without remainder, and factors are commonly found in pairs. So for factors of 24, 1 and 24, 1 times 24 is 24, 2 times 12, 3 times 8, 4 is 6, and often we'll put them in order so we can see them. So 1, 2, 3, 4, 6, 8, 12 and 24 will divide into 24 without remainder. Common factors are factors that exist in two lists of numbers. So if I'm looking at the common factors for 24 and 54, there are the factors of 24, there are the factors of 54. 1, 2, 3 and 6 exist in both lists. So the common factors of 24 and 54 are 1, 2, 3 and 6. The highest common factor is the biggest number that's common to both lists. So if we have 24 and 54 again, the biggest number we know from this list is going to be 6. So the highest common factor, the HCF, of 24 and 54 is 6. Nice and easy so far. Now once we get past relatively small numbers, using a list is hard work, so we'll use prime decomposition. So if we were going to consider 140 and 110, here's 110. The prime factors of 110 are 2, 5 and 11, and for 140 will be 2 squared, 5 and 7, and then what we do is we look at what's common in the prime factors. So we have a 2 here and at least one 2 here, and a 5 here and a 5 here, so 2 times 5 is 10. That is the highest common factor of 110 and 140. It gets a little bit more difficult when we've got two. I'm just going to bring these across a bit so we can see them. I do this with my pen. Grab all of this. Right around there, right up here. And then move it all across. Come this way. Otherwise, we won't be able to see it. So bring this back. Okay, so the highest common factor of 441 and 588 is 3 squared times 7 squared for 441, and 2 squared times 3 times 7 squared for 588. The common factors, not 2, just be plain old 3, because this one doesn't have a 3 squared and 7 squared in both. So 3 times 7 squared, or 3 times 49, which is 147. Okay, now if there are no common numbers in these lists, we call them relatively prime or coprime, and their highest common factor will be 1. Every natural number has a common factor of 1. We just don't tend to list it at the bottom of these trees because it's a bit superfluous. Once you know what I've done above, you can do questions 1 to 7. Some of them are really difficult, so I've put a star next to those and we'll do them after school. Once you've got a handle on that, we then go and learn the division algorithm. So we can express any number and its factor as the number is equal to some factor multiplied by a number plus a remainder. So in the case of 37, if we were wanting to factor it with 3, 12 3s are 36, so there's 12 lots of 3 and 36 with one remainder. N would be 37, A would be 12, Q would be 3, and R would be 1. And for 19, we can do the same thing with 3. 5 lots of 3 goes into 19. Oh, that's not right, is it? If we're doing factors of 3, 6 lots of 3 would be 18, with a remainder of 1. So A would be 6, Q would be 3, and R would be 1. I knew the remainder couldn't be 4 because with a factor of 3 we have an extra multiple available. Okay, so once we understand how this little equation works, we can use it with the Euclidean algorithm to solve for very large numbers where factor trees just become too difficult to work with. So if we wanted to find the highest common factor of this number and this number, so what's that, 3,542,940 and 388,800, what we would do is we'd see how many times this number we'll go into that number, in case it's 9 times with the remainder of this. Then we do the same thing again, except now we're going to let n be that number. So stick that out the front, make that the new factor, and then we find out that this number goes into that number 8 times with the remainder of this. Put that out the front, make that the new factor. This goes into this once with a remainder of 4860. Bring that out the front. Bring that out the front, make that the new factor. That goes into this number 80 times with no remainder, telling us that the highest common factor is 4,860. Now, using a factor tree, that would be particularly ugly. We've done it in 4 lines. Quite neat. Once you've figured out what's going on here and you can understand this little algorithm, be careful with this step if you're doing it programmatically on a computer, because you have to assign q to a variable first so you don't override it, but that's a programming issue, not really a mathematics issue. And if you know how to do this, you'll be able to do question 8 now. And that's all for this week, and I'll see you soon. Thanks everyone, bye.